On a sunny day, a man was diving in shallow waters near South Africa. At one point, he saw something that didn't catch his eye at first. A pile of shells that looked as if it had been put together. Maybe by some other diver, he must have told himself. But out of all these shells came the most unusual of creatures, an octopus. The gorgeous underwater animal looked straight at the man before swimming away. Impressed by his new acquaintance, the diver started visiting the octopus every day. He watched it use shells and seaweed to protect itself and learned how it hunted and cared for its eggs. All these encounters became the basis for a now famous documentary. In the movie, the diver wanted to study the relationship between a wild octopus and its observer. Initially, the octopus was a bit too shy to let the man get close. But over time, it began to trust him and even explored his body. At one point, the octopus even rested on the diver's chest. The man soon began to look at the underwater creature as his octopus friend. Sure, the documentary did make it look like a true friendship, but that was most likely because of all the close-ups and eerie music. But you can't really know what the octopus is thinking. Maybe what looks like tenderness is just curiosity or confusion. Maybe an apparent hug is really just a defense mechanism. Some people may love octopuses, but can they really be friends with a human? Until they learn to talk, I guess we'll never know. That doesn't make an octopus less of an interesting creature though. Apart from those quirky sets of tentacles, obviously, octopuses have another characteristic that sets them apart from other sea creatures. A recent study that involved studying the footage of octopuses living underwater shows that they sometimes develop this unusual behavior. They seem to throw things at each other on purpose. It can be anything from dirt from the bottom of the sea to shells or rocks. Octopuses are known to be solitary creatures, so when something or someone, like an underwater camera person, gets too close to them, they might lash out. Just as we have yet to discover the limits of our galaxies and constellations, we know very little about the bottom of the sea. It's one of the reasons why we find it so hard to explain the behavior of some underwater creatures. The truth is, we don't have good enough technology able to deal with harsh conditions and a limited amount of light underwater. You might have asked yourself at one point, what's the deepest part of the ocean? It's called the Mariana Trench. We don't really know exactly how deep this giant hole is, since it's too difficult to measure, but it's somewhere around 6.8 miles deep and 5 times longer than the Grand Canyon. This massive underwater trench was first studied back in 1875 with the help of a weighted rope. Back in 2012, a Canadian film director reached the bottom of the trench in a submersible vessel called the Deep Sea Challenger. Some of the most bizarre creatures on the planet were discovered here, including the Dumbo octopus, the sea cucumber, and the goblin shark. The Mariana Trench got its name from the nearby Mariana Islands, which were named Las Marianas in honor of Spanish Queen Mariana of Austria. The Mariana Trench might be the deepest part of the ocean that we know of. But one other mysterious phenomenon that's interesting for researchers is called phantom bottoms. In the late 1940s, when the sonar became standard equipment, ships and submarines noticed unexpected signals coming from the ocean. Those signals came from areas where no seafloor was supposed to exist. What's even more mysterious is that this fake seafloor appeared to move. One researcher at Scripps University found out that these phantom bottoms showing on maps were indeed alive. They were made out of a layer of jellyfish, shrimps, and other deep-sea creatures. The reason why they move is that they rise to the surface at night to feed. To top it all off, even the way these creatures move is kinda calculated. They don't just move randomly, but seem to gather together by species. We used to believe underwater animals behave this way only to avoid being caught by predators. It's a mystery to scientists why they group in the same way to form a fake seabed. our curiosity about the deep waters doesn't stop at the seafloor. If you went on a vacation to the beach when you were young, you probably remember the fun of digging in the sand. As the hole got deeper, you may have asked yourself, could I dig all the way to the other side of the Earth? None of us have ever found out. Our parents took us home when it got dark and chilly. Scientists are more reasonable when it comes to this subject. For starters, they know the best place to start digging would be underwater, since those regions are already deeper than what we can find on land. They also do not have the ambition to drill a tunnel through Earth. It's not even possible. That's mostly because of the extreme heat and pressure inside our planet. Even if we could technically dig a tunnel, it would not be safe to travel through it. However, reaching the mantle and retrieving a sample would be a huge scientific achievement, similar to landing on the moon. What we live on is called Earth's crust. Underneath it, there are other layers called the mantle, outer core, and inner core. Researchers have been trying to drill into Earth's mantle since the 1960s, but they haven't succeeded. Some failed due to technical issues, and others were unlucky and chose the wrong places to drill. Our planet's mantle is made of molten rock. Wouldn't that be dangerous if we ever reached it? Scientists say we have nothing to worry about, though. If and when the drillers eventually pierce through the crust underwater, hot molten rock won't pop up the hole and spill onto the seafloor like it would during a volcanic eruption. Mantle rocks aren't solid, sure, but they move slowly, at the same speed as your fingernails grow. Another of those famous deep-sea mysteries is that of the 1997 Bloop. You heard that right. I'm talking about a weird sound that seemed to come from deep under the waves. People heard it in the South Pacific. No one had ever recounted a sound like that before. Some thought it must have been emitted by a strange creature living deep in the ocean. It didn't help that the noise came from a location mentioned in a story by famous writer H.P. Lovecraft. In his story, it was a creature called Cthulhu that lived there. In the novel, the author described it as a large, human-like monster with tentacles on its face and wings on its back. For many years, people tried to figure out where the noise came from. It wasn't until 2005 that they concluded it was from icebergs breaking off of glaciers. Some people still don't believe that this explanation truly makes sense and are searching for a different reason for the Bloop. If creatures living outside of our planet ever decided to come to visit, you wouldn't expect them to go straight to the bottom of the sea, right? Well, some people claim there's a sort of spaceship on the ocean floor, discovered in 2011. It's basically an oval-shaped object located on the bottom of the Baltic Sea. In 2012, a team of divers explored the anomaly and found what appeared to be a staircase and other structures on its surface. This only added to the belief that the large object had been made by someone and wasn't just a natural phenomenon. Even more bizarre, close to the unidentified anomaly, the explorers' electrical equipment, like sonar instruments and satellite phones, started to malfunction. Some scientists believe it just to be a glacial deposit or some other natural formation, but they still don't know for sure what it is. Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up, But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more, but getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seemed like they might have been made by bacteria. But hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system. For years, scientists have been struggling to explain bizarre sounds, some repeating, some heard only once, that come from the dark depths of the ocean. From bewildering hums to worrying bloops, the water transmits outlandish acoustic phenomena. One of these mysterious noises got named the upsweep. For the first time, this long train of sounds was registered in 1991 in the Pacific Ocean. One of the most unusual things about this signal is that it keeps changing, as if trying to confuse researchers even more. Like some unearthly howl, it varies from high to low frequencies and then back again, and you can hear it better in the spring and fall than in the winter and summer. Why the upsweep? It's simple. The sound travels from the bottom of the ocean towards its surface, as if sweeping up. Scientists do have a theory explaining this phenomenon: the activity of undersea volcanoes. Hot lava pouring into ice-cold ocean water could theoretically create such noises, but there's no proof found yet. Plus, the sound has been declining since 1991, even though it can still be detected. The bloop is the name given to an ultra-low frequency and incredibly powerful underwater sound that was recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The bloop continued for approximately 1 minute. Having started from a low rumble, it gradually rose in frequency. It also kinda mimicked the noise created by marine animals, but its volume was so great that no living creature known to science could have made it. When the bloop occurred, underwater microphones managed to record it from a distance of 3,000 miles away. Rumor has it that the noise might have something to do with the fictional half-octopus monster Cthulhu, or some other colossal deep-water creature. But if you don't believe in monsters, science has another explanation: iceberg fracturing. The thing is that ice quakes recorded in the Scotia Sea resemble the mysterious bloop a bit too much for it to be a coincidence. The whistle resembles this annoying sound when a kettle of boiling water is telling you it's time to make a cup of tea. But even though it may not be as blood-curdling as some other bizarre ocean sounds, it doesn't make it any less mysterious. Plus, the whistle is very elusive. In 1997, only one underwater microphone was able to pick it up, and therefore, researchers didn't manage to pinpoint the source of the noise. The most likely cause of the sound is an eruption of one of the submarine volcanoes. Have you ever heard of Julia? No, not your neighbor. I'm talking about this otherworldly sound. Listen to it. It was recorded in 1999 by the U.S. National Oceanic and Atmospheric Administration. The source of the sound was most likely a large iceberg that ran aground somewhere in Antarctica. The sound was so loud that it was heard over a huge territory, and its duration was about 2 minutes and 43 seconds. Slow down. That's the name given to a sound recorded in 1997 in the equatorial Pacific Ocean. The sound was called this way because it slowly decreased in frequency over 7 minutes or so. It's been picked out a few more times since it was recorded for the first time. The source of the sound isn't very mysterious. Most likely, it was produced by a massive iceberg that became grounded in Antarctica, or it was caused by moving ice. By that, I mean the friction produced by a large ice sheet moving over land. The loneliest whale sound is often called the 52 Hz whale because the animal that creates it calls at a unique for these creatures frequency. When you listen to this sound, it sounds like a low bass note. At the same time, it's much higher than the normal frequency of the whale call, which rings between 10 and 40 Hz. Interestingly, scientists have been listening to the world's loneliest whale for decades, but haven't managed to figure out its precise location. Nobody knows whether the mammal is male or female, what species it is, or if the animal is still alive. After all, for the last time, its call was recorded in 2004. Earth-shaking booming sounds have been reverberating off some parts of North Carolina for more than 150 years. Called Seneca guns, they're most often heard near the coast. The sounds are so powerful that they often rattle window panes and sometimes vibrate entire buildings. They can last from 1 to almost 10 seconds. Even though scientists haven't cracked this mystery yet, there are some theories. They range from earthquakes to severe distant storms and quarry blasts. But even though the ground trembles every time the phenomenon occurs, no seismic activity coincides with these events. So far, scientists have come to the conclusion that the mysterious sounds happen in the atmosphere, not on or under the surface of our planet. If this theory is true, bolides might be the answer. These extremely bright meteors often explode once they enter Earth's atmosphere. Or Seneca guns might be born in the ocean. Sometimes, when enormous waves collide far away from the shore, you can hear it, even if you're nowhere near the coast. Seneca guns are a type of skyquakes. You don't need to travel to a particular part of the world to hear one of those. Mysterious sonic booms ramble from the sky everywhere, from the US to India and Japan. Just like Seneca guns, this sound phenomenon occurs mostly near the coast or a big body of water. Rattling glassware and windows in the nearby houses, skyquakes could be connected with ultra-fast airplanes breaking the sound barrier. But people started hearing the first skyquakes in 1824. The theories trying to explain this phenomenon include sand dunes shifting, meteors entering the atmosphere, distant volcanoes erupting, Earth's crust cracking during earthquakes, and even gas bursting out of underground vents in the sea or lake bottom. In different countries all over the world, people get paralyzed with fear after hearing otherworldly trumpet sounds that seem to be coming from the sky. The inhabitants of the US, Canada, Australia, Germany, and the Philippines have already heard this hair-raising noise since it was first recorded in 2008. These sounds are sometimes called the sound of apocalypse. And although until recently, nobody could understand the origin of the sounds, NASA claims that there is nothing to be afraid of. The noise can be coming from our own planet. Usually, it's quiet and thus inaudible to the human ear. But when it gets louder, the outcome is the very trumpet sounds that scare people all over the world. Bristol hum started in the 1970s when hundreds of Bristol inhabitants began to talk about a bizarre noise audible only at night. The noise was a low-level hum, and nobody could identify or trace the source of the sound. But the strangest thing about the noise was that one day, it stopped as abruptly as it started, but not before people in other towns across Britain reported hearing similar sounds. Some time ago, the mysterious sound returned. In 2015, a group of French scientists claimed that they had solved the mystery of the Bristol hum. They stated that the culprit was ocean waves that made the ocean floor vibrate. But while it was all good and well, it didn't explain why the sound was around for only several years or why it chose to return. If you ever come to the town of Taos in New Mexico, don't let another strange and unexplained phenomenon send you running for the hills. This phenomenon is a faint, low-frequency hum ringing in the desert air and grating on your nerves. Even stranger, only 2% of people who live in Taos hear this noise. But for those who do, it's unstoppable torture. On top of that, everyone describes the sound in a different way, from a quiet whir to an eerie hum or even persistent buzz. And while some people believe that the Taos hum is the result of unusual acoustics, the others suspect a bad case of mass hysteria. No one has located the origin of the hum yet. Oh wow, there's a hole in the bottom of the ocean! It seems that the ocean has a leak, but it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's Oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's Oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad, In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes, and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish. Okay, this one kinda looks normal until you raise it to the surface. The goblin shark, Sloane's viperfish, zombie worms. Ugh. Yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found. Hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn! How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with irregular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship, the big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next-to-water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under half an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses. Many terrifying animals live deep beyond the waves, like this vampire squid living 3,000 feet below the surface in almost complete darkness. This animal has a cloak, like a vampire's. That's why it's called the vampire squid. Deep down at the bottom, it can't use ink to defend itself. So this animal has developed an unusual tactic. It glows slightly to scare away predators. If this tactic fails, the vampire squid can turn its body inside out, revealing tiny spikes. When you translate its scientific name, Vampiroteuthis infernalis, it literally means vampire squid from the nether. Despite its terrifying looks, it's a harmless ocean animal. This previous creature was not from space, but this object definitely is. Before Elon Musk found a way to reuse rockets, NASA would simply drop old ones after launching astronauts into space, most of the time in the ocean or deserts. In 2012, Jeff Bezos launched a mission to find the Apollo 11 rocket. They found it by using sonar, but it was in terrible condition. It was sitting on the bottom of the ocean, not far from the predicted site. They were able to rescue the engine and reconstruct two of them. The most famous lost city is Atlantis, but sadly, we still haven't discovered it. However, Heraklion was also just a myth until one British pilot saw something that looked like a city while flying over the Mediterranean Sea. He reported it, and 60 years later, a group of divers went there. They were shocked when they found an entire city underwater. It was loaded with artifacts that could tell us a lot about the history of the place. Now it's one of the best underwater archaeological sites in the world. It's believed that the rising sea caused the whole city to go underwater. The Titanic sank in 1912. The wreck was claimed to be officially discovered 74 years later. In reality, though, a fisherman found the Titanic 8 years earlier while fishing in the Atlantic Ocean. He was pulling out his net when he spotted a head stuck in it. Luckily, it was just a doll's head. Years later, after the fisher had passed away, his son sold the doll to a doll collector. She did a lot of digging and research on every person who had a porcelain toy on the Titanic. She found the owner of the doll. Ava Hart was on the Titanic and had a doll with her. Ava survived the catastrophe by a miracle, but her toy didn't. Hart even wrote about the doll in her journal, and every detail matched the toy found by the fisherman. The tripod fish lives deep in the abyssal zone, around 20,000 feet below the surface. It's adapted to such immense depths and uses its tripod fins to stay still on the bottom. This creature doesn't have big eyes, but even if it did, these eyes would be useless in the darkness. Instead, the tripod fish uses its fins like antennas to detect any movement in the water. This creature doesn't have much luck when it comes to its love life, so it had to develop unique tactics to reproduce. One fish can be both male and female. The next bizarre creature is the lizardfish. It has tons of razor-sharp teeth, a huge mouth, and really big eyes, which it uses for hunting. All this makes the animal look freaky. The lizardfish lives at depths of around 11,000 feet in the midnight zone, where there is zero light. This freak of nature basically eats everything it can fit inside its mouth, from small fish to other lizardfish. On the other hand, when they see other reptile fish, they probably fall in love instead, because finding mates at those depths is not an easy task. Like the tripod fish, the lizardfish can be both male and female at the same time. When you think of a river, you usually picture it on land. Still, nature is quite unpredictable, and it created a river flowing under the ocean in California. It's running at a depth of around 2 miles. This river has everything that an ordinary river has: sunken logs, trees, and rocks. And despite its uniqueness, it's not the only one in the world. There are also others in the Amazon and Greenland. A terrifying creature was discovered near Angola's coast by a remote operating vehicle. It looks like it doesn't have a head or a body. It was sitting at a depth of around 4,350 feet below the surface. After doing research, scientists concluded it wasn't anything from a sci-fi movie. It was just a cluster of siphonophores stuck together. In 2015, some random guy was diving in Caesarea, and something shiny caught his eye. He reached out, grabbed it, and realized it was a gold coin. After that, he examined the bottom and found out that there were many more. He reported the incident to the local authorities, and they concluded that he had found Arabic treasure. The coins were made of solid 24-karat gold and were a few thousand years old. But due to the perfect salinity and temperature, they looked brand new. The coins belonged to a ship carrying cargo. It was caught up in a storm and unfortunately sank. One of the weirdest things ever discovered was found in the Baltic Sea. It's an anomaly that looks as if it was created by a different civilization. It was discovered by Swedish researchers, and they basically had no idea what it was. They had to ask tons of other scientists for their opinions. When you look at this formation from above, it's 200 feet long and looks exactly like a fallen spaceship. It's hard to believe that it's a natural formation, but spoiler alert, it's totally made by nature because the Baltic Sea has gone through many erosions throughout history. Most likely, the bizarre formation is the result of these processes. A group of divers in Madagascar were shocked when they found this 7-foot monstrosity of a knife on the seafloor. The speculation started immediately, and many said that the knife was from some giants that had fought megalodons and lived on Earth thousands and thousands of years ago. That could make a nice story, but the knife is most likely a movie prop that was lost at sea. One of the ocean's most bizarre animals is the frilled shark. It's believed that this fish is the reason for all those sea serpent stories that sea explorers of the past wrote about. These animals live pretty deep in the ocean, but sometimes they can be seen in shallow waters. It's super rare, but possible. The frilled shark has a big mouth sporting around 300 teeth. It also has a long body that looks like a lizard's, and it is truly a unique species of shark. Its prey can be half of its size because this shark's stomach is like that of a snake, and it can swallow huge fish or crustaceans. Spotting a few worms in your garden is no big deal, but after seeing a 26-foot-long one in the ocean, you will make your wetsuit a little wetter. This worm is super rare, and it's completely harmless to humans. It's actually not a giant worm. It's a cluster of zooids that are stuck together in a worm-shaped formation. They usually only eat plankton, bacteria, and other tiny things that can be found in the ocean. Probably the scariest thing in the ocean that is 100% real is the magna pinna, which can be found at crazy depths of 20,000 feet below the surface. This monster looks like an underwater Slender Man, but it's just a squid with really long tentacles that can reach a terrifying size of 8 feet. This guy has only been seen a few times, and basically, we don't know much about this creature so far. Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called Limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nyos in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An Anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metalworkers use. Duh. The air from the anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools. caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Mockstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future.
So, a mysterious discovery was made deep in the Red Sea, the so-called death pools. Woo, that's scary. In 2020, researchers embarked on a dive into the Red Sea. The mission spot was in the Gulf of Aqaba, between Saudi Arabia and Egypt. Near the end of their expedition, as they ventured deeper into the darkening waters, they noticed some strange seaweed floating above the seafloor. They decided to use a remotely operated vehicle and investigate it. Suddenly, they discovered these strange, motionless lakes of water within the sea. These are called brine pools. They're basically pockets of salty water deep on the ocean floor. And when I say salty, I mean it. Sometimes they're up to 8 times saltier than the ocean water itself. Mysteriously, they don't mix well with the surroundings. They formed millions of years ago, sometime during the Miocene epoch, back when weird creatures roamed the Earth, like me, and deeply buried mineral deposits dissolved into the water. The largest pool spans about 170,000 square feet. Meanwhile, 3 smaller ones are under 107 square feet each. At first, this discovery didn't seem that scary. But here's why they're so horrifying. Not only are they disgustingly salty, they also lack oxygen. Now hold on a sec, isn't that normal for something that's underwater? Well, it turns out the Earth's waters are full of oxygen, and at least half of this element on our planet comes from the oceans. Just like plants on land, marine plants such as phytoplankton, seaweed, and algae munch on sunlight and produce oxygen through photosynthesis. They release lots of it into the surroundings. Marine life then eats half of it, so only about a quarter of the oxygen that we breathe actually comes from the oceans. Just like us, sea creatures need this element to survive. Without it, they can't breathe and support their metabolism to live. That's why these pools are super dangerous for most of them. It's like a puddle of thick syrup for bugs. When they get in, the poor things immediately suffocate and pass away. Which is why the pools are surrounded by a graveyard of marine animals. But let's see how these things can exist in the first place. Have you ever tried making ice cubes from salty water? Spoiler, it's pretty hard. When you add salt, the water gets harder than usual to freeze, a phenomenon that has a funny name, freezing point depression. Oh, that's because salt interferes with the hydrogen bonds between water molecules. As it finally freezes, stuff like particles, dirt, or dissolved salts get pushed out to the sides. As a result, the salt's kind of squeezed out of the ice crystals and gets trapped near the edges in small bubbles or pockets. Something similar happens in the ocean when seawater starts freezing under super cold polar caps. The salt doesn't freeze with the water. Instead, it gets pushed out, forming a super salty cold liquid, the brine. And then it sinks down to the ocean floor. On a large scale, all this process also helps currents to form. Despite being so dangerous, the pools are still full of microbial life, because microbes couldn't care less, they'll survive anywhere. There are literally thick mats of them in the brines. There are also some salt-loving creatures, like shrimps and eels, hovering around the pool's edges. They're being super creepy, waiting to catch unsuspecting prey that ventures too close to the toxic death pool. Ew. Well, it sounds icky, I know. But this discovery gives us some fascinating insights into how life might have originated on Earth. We already know from the evolution theory that we came from the ocean, But now scientists think that life might have begun in the deep sea in some super dark, oxygen-free places. These brine pools are like time capsules. They're one of the closest things we found to the early Earth. They can tell us the planet's history of earthquakes, floods, tsunamis, and more. For example, they have some traces of rainfall that happened over 1,000 years ago. And they can also help us search for life on other water-rich planets. For example, Mars most likely used to have huge oceans on it. Now, NASA scientists want to send a special instrument called HABIT for a special red planet mission to study things similar to our brine pools. This will tell us more about how life appears and survives in the universe. There is lots of unexplored fascinating stuff like this in the Red Sea. That's why scientists conducted the so-called Decade Expedition and spent around 5 months exploring the place. This expedition was launched by the National Center for Wildlife. They made so many remarkable discoveries that now we've got 77 new research papers. For example, they found over 10 blue holes, incredible underwater sinkholes that host unique ecosystems. They also learned that dolphins can use those blue holes to protect their young from predators. Scientists also found traces of great white sharks, a creepy community of deep-sea lanternfish living in low oxygen conditions, and even a new coral species. It's the most resilient deep-sea corals that also vibe just fine without oxygen, like microbes we mentioned. Speaking of which, research also showed us some new ancient thermal vents and large blobs of microbial formations near Farasand Island. Now, can you believe that with all that, we only explored 5% of the ocean? It's divided into several layers based on depth. Each layer becomes darker and more isolated from sunlight as we go deeper. The places that no sunlight can reach are terrifying. Now, the fun, cute layer with dolphins and turtles is called the epipelagic or sunlight zone. It's so tiny, but even this layer is about 650 feet deep. Then we have the mesopelagic or twilight zone. It's the layer of mysterious octopus, shark, and other loners which extend to about 3,000 feet down. And then the horrors begin after this one. We encounter the bathypelagic or midnight zone. It extends to 13,000 feet below the surface, about a half of Everest above you. Here we have the famous poor blobfish, squids, and anglerfish. Below it is the abyssal zone. It extends to about 20,000 feet deep. Since there's not much sunlight or oxygen, as we mentioned, most creatures here are quite small, like tube worms and shrimp. The darkness continues until we arrive at the scariest place of the planet, the place full of trenches formed by tectonic plate movements, the Hadal Zone. It's named after Hades, the deity of the underworld in Greek mythology. Just like Hades' realm is dark, remote, and guarded, the Hadal Zone is the deepest and most depressing part of the ocean. It starts at depths of around 20,000 feet and can go down to 36,000 feet and more. The famous Mariana Trench also belongs to this zone. Only 3 people in history have ever explored these depths in person, making it one of the least explored and most mysterious places on our planet. However, despite crazy high pressure, near freezing temperatures, and complete darkness, there are still things who manage to survive here. Guys like amphipods, which are critters who feed on dead material sinking from above, and the Hadal snailfish, which lives as deep as 27,000 feet. So scientists used to assume that if there's no sunlight, there wouldn't be that much oxygen around. But one day, a research team decided to measure the levels of oxygen in one of those deep zones. Surprisingly, the levels were super high. They checked the equipment thinking that it was malfunctioning, but nope, all the sensors showed the same thing. Turns out the oxygen was somehow generated by rocks. These small potato-sized rocks on the seafloor are called polymetallic nodules. They're rich in metals like copper, nickel, and cobalt, and they're basically like small batteries. When you put a battery in salt water, it can produce bubbles of gas, a process called electrolysis. In the same way, these rocks create tiny electric currents, which are powerful enough to produce the same gases, splitting water molecules into hydrogen and oxygen. It's the first time we saw oxygen being produced by some non-living minerals. This is what scientists now call dark oxygen. It turned out that about half of large marine species, or megafauna, we're living just on dark oxygen alone. All these discoveries are reshaping our understanding of where and how life could evolve. It means that we might be able to find life on other planets or satellites with low oxygen conditions, like Enceladus and Europa, the moons of Jupiter and Saturn, and they have large bodies of frozen water on them. Wow!
Okay, let's play a little guessing game, shall we? Can you name the 6th largest river on Earth in terms of volume? That's the amount of water that flows through a waterway. The first couple of rivers are easy to list. Number 1, of course, is the Amazon River in South America. Then we have the Congo in Africa, and the Ganges in India. Feel free to name all the rivers on the planet. You won't get any closer to the answer. Why? Because this river is not on the surface, but underneath the waves of the Black Sea. In 2010, a team of scientists discovered this river while studying the Bosphorus Strait in Turkey. Sonar scanning revealed a channel at the bottom of the Black Sea. The channel had water flowing through it. It turned out that at places, it's 115 feet deep. That's 3 times as tall as your average telephone pole. This flow of water acts like a real river. It has rapids and waterfalls, and its volume is 350 times greater than that of the River Thames in London. Talk about a strong undercurrent. If it was a surface river, it would really be in the top 10. Bad news for the Madeira River in Bolivia and Brazil, the present number 6. But how did this underwater river form? The answer lies in the amazing features of the Black Sea. It gets its water from 2 main sources. The first are the rivers that flow into it, like the Danube, Dnieper, and Don. Lot of D's there. But more importantly, they are all freshwater waterways. On the other side, quite literally, there is the Mediterranean, and it's salty, like a lot. When this salt water gets inside the Black Sea, it goes straight to the bottom. You see, fresh water is lighter than salt water. This creates stratification. It's a fancy term that simply means that the 2 types of water don't mix together. Salt water has a higher density, so it drops right down to the bottom. If you want to see how that works, you can do an experiment at home. Pour mineral water into 1 cup and salt water into another. Table salt will do. Then put a grape in each cup. You'll see how it immediately sinks to the bottom of the cup filled with fresh water. The grape will stay afloat in the cup filled with salt water. The same thing is happening inside the Black Sea. But there is another side to this phenomenon. The upper layer of water is rich in oxygen. This means it can support life. The bottom layer, however, is anoxic. Yep, you guessed it. This means there is no oxygen at the bottom. But this isn't a bad thing. Because of this trait of the Black Sea, shipwrecks are able to survive for centuries. Oxygen decomposes wood. And from what material did the ancient people make their ships? That's correct, timber. Recently, in 2018, scientists discovered the oldest Greek shipwreck on Earth. The merchant ship lies more than a mile deep at the bottom of the sea. Experts estimate that the vessel is 2,400 years old. The wreck was valuable for historians to study all the elements of ancient ship construction. From the mast to the rowing benches, it's all intact. The wreck lies some 50 miles off the coast of Bulgaria, but no one has seen it in person. Explorers sent a deep-sea ROV, or remotely operated vehicle, to film the wreckage. It was impossible for a diver to go down. But the Black Sea doesn't look that huge on a map. Could it be that deep? Oh yes, it's way deeper than people think. You could stack 6 Empire State Buildings at the deepest point of the Black Sea, around 7,257 feet. This inland sea isn't the only place on Earth where researchers have discovered shipwrecks and underwater rivers. One of the largest channels running along the ocean floor lies off the coast of South America. It runs from the mouth of the mighty Amazon and into the Atlantic Ocean. Studying underwater rivers isn't an easy task. The depth and the strong currents make it impossible to send in divers. Even the equipment for underwater research has to be sturdy. Otherwise, The current will just wash it away. That's why the underwater river in the Black Sea was ideal for scientists to explore. Earth's oceans and seas are powerful. But, lucky for us, there are places where divers can admire underwater rivers. Ever heard of a cenote? Sounds Spanish. Well, that's because it is. Cenotes are underground caves. They form after the limestone above collapses, revealing the groundwater under them. The term cenote is associated with the Yucatan Peninsula in Mexico. Ancient Maya used them as water sources. In the Mayan language, the word cenote meant sacred well. Researchers estimate there are some 10,000 cenotes spread across the Yucatan Peninsula. You can also find them in other places, such as Cuba and Australia. Beauty is in the eye of the beholder, but unofficially, the most beautiful cenote is located just south of the town of Tulum in Mexico. The name reflects the cave's divine beauty, Cenote Angelita. But people don't visit this cenote to go swimming. Its bottom is much more interesting. A scuba tank is all you need to finally admire an underwater river firsthand. The waters are dark and foggy, so divers use powerful flashlights. After a 100-foot dive, a marvelous sight appears. An underwater river with trees along its banks. Some of them even have green leaves, just like any other water flow on dry land. But it's not really a river. Here comes the fascinating part. Remember how saltwater and freshwater don't mix? Well, the river the divers see is actually a thick layer of fog between the two types of water. 3 feet of hydrogen sulfates to be exact. This is the compound that water processing plants use to remove chlorine from drinking water. The substance is so heavy that the fog it produces moves independently from the surrounding water, and it creates an illusion that a river is flowing underwater. But there are other real rivers that play tricks on you. Take, for example, the Mystery River in Indiana. It's the longest underground river in the United States. Explorers discovered the river and its cave system, Blue Spring Caverns, in the 19th century. Nearly 3 miles of the river are navigable. Isn't that impressive? You can book a boat tour on a river that you can't even see. But the most mysterious river on the planet is the Saraswati River in India. The coolest part about it is that it doesn't exist. It was an alleged river only mentioned in ancient literature. For centuries, people thought that it was just a myth. Then satellite images showed that it might be real. Ancient texts spoke of a major confluence of 3 mighty rivers, the Ganges, Yamuna, and Saraswati. The first 2 are visible today, but where's the third one? That's what scientists decided to find out. Images from an American satellite showed the presence of underground water in the area. Until then, researchers thought that these were paleochannels. This simply means that water flowed through them a long time ago. But, to their surprise, it appeared that there was still water inside these channels. Scientists estimated that the Saraswati River flowed above the ground some 5,000 years ago. But it didn't dry up completely. It just went underground, some 200 feet below the ground. Local experts believe that the river still slowly flows into the sea. The Saraswati River got hidden under the desert sand. This was a natural process, but many rivers have been forced underground because of human activity. In London, England, several dozen small and medium-sized rivers now flow under the ground. Maps from the 19th century still show them as rivers, but today they only exist in the names of the streets that were built above them, such as Fleet Street. The same thing happened in New York, but this doesn't mean that these streams have disappeared for good. When engineers want to rebuild or modify a building, they still consult city maps from centuries ago. No one wants a long-lost brook to flood their basement.
The Amazon River travels through 9 South American countries at a length of over 4,000 miles. Still, it's impossible to cross it by a bridge. With the river being the main highway, traveling through this dense forest, and so few areas populated around the river, there's just no reason to have one. The river can rise up to 30 feet, and the river crossings that were only 3 miles wide can expand to over 30 miles in just a few short weeks in certain spots, making a bridge nearly impossible to build here. In New Zealand, in the coastal town of Mauriki, there are huge spherical boulders. Some rocks are 6.5 feet tall and weigh about 7 tons, as much as 10 cows. Ooh, there's a 10-cow boulder. Maori legend has it that these rocks are from the remains of the goods from a large shipwreck that happened hundreds of years ago. From a more scientific perspective, it's sand and gravel combined to form these giant boulders. Waves and winds give them a smooth, round appearance over time. The whole process might take millions of years. Indonesia's Kaiwan Ijen volcano is famous for a stunning turquoise-colored lake sitting at the top of the peak, but don't dip in. It's an acid lake. But its scariest part is the sulfuric gases leaking out when lava flows freely, reaching temperatures hotter than 1,000 degrees Fahrenheit. When those gases come in contact with the air, they combust into a spectacular electric blue flame. That's why the volcano has blue lava. The island of Surtsey, south of Iceland, was formed over 50 years ago by a volcanic eruption. It all began back in 1963 when a powerful volcanic eruption created one of the youngest islands on the planet. All sorts of bacteria, fungi, and molds began taking over the island, leading to numerous other animals finding their way here, like seals and birds. Birds and ocean waves deposited seeds all over the island. Sadly, the island's getting smaller now because of water and wind erosion. Located off the coast of Brazil, there's an island called… I'm a bit rusty on my Portuguese, so here it is on the screen. It looks perfectly untouched and pristine. Bad news? Dangerous snakes overrun it completely, so take a doctor with you in case you want to go there. Over 4,000 of the golden lancehead vipers inhabit this island. These 3-foot-long snakes are among the most venomous in the entire world. I think I'll skip that. Landing down under, you can see the Opera House, Uluru, lots of kangaroos, and catch the strangest wave of the world, Wave Rock in Western Australia. It's not made of water, but stone. It can be up to 50 feet tall and almost 300 feet long. It's especially incredible after rains in winter when the Western Australian wildflowers fill up the entire landscape. In Atlanta, there's a World of Coca-Cola museum. The formula for the secret recipe is in a large security vault, heavily guarded at all times. Only a handful of people can get through those vault doors. Since its creation in 1886, the company has kept it a secret for only the most honest employees. In 2006, a former worker tried to sell the formula to Pepsi, only for Pepsi to call the police and inform Coca-Cola. The Polka Dot Lakes is a must for anyone who is in British Columbia. After the summer's scorching heat evaporates the lake's water, it leaves behind yellow, blue, and green water spots. These pools are full of all sorts of minerals, like sodium, calcium, and magnesium sulfates that get concentrated in the pools. You can't get too close or even dip your feet into them. A fence protects the entire lake with a sign about how culturally and ecologically sensitive the area is. In Death Valley, California, there's a mystery of the sailing stones. Since the early 1900s, the mystery of how all these stones were seemingly moving by themselves across the desert floor baffled everyone. Some believe that the rocks move by thin pieces of ice around the stones pushed by winds after winter. No one ever saw any of these rocks moving until 2014. Scientists set time-lapse recorders, and the footage showed the rocks sliding along the ground over time. The marble caves in Chile, located in the beautiful area of Patagonia, formed from over 6,000 years of waves wearing down the rocks. The crystal blue walls reflect the vibrant turquoise water, making it perfect for kayaking. Walking in Chestnut Ridge Park in New York, one can see an eternal flame. What makes this one stand out, though, is it's underneath a waterfall. Occasionally, the flame will go out for short periods, but it will light up again. Sometimes it's thanks to certain hikers along the way. If you ever stop your car on a magnetic hill in New Brunswick, Canada, you'll see the car might start rolling backwards up the hill, all by itself. While it looks like it's moving the wrong way, this is just an illusion. There are several hills like this all around the world. What looks like an incline is the opposite, all because there's no horizon for perspective. The brightest bioluminescent bay in the world, called Puerto Mosquito, is located off the coast of Puerto Rico. The bay is named for the pirate Roberto Cofresi and his small boat El Mosquito, not after those annoying insects. During the summer months, you'll have glassy water at night with millions of tiny microorganisms bumping into each other and emitting blue light. The Chocolate Hills in the Philippines is a group of unusually shaped hills located in the middle of the island of Bohol in the Philippines. There are 1,000 to 2,000 discovered so far. They have nothing to do with chocolate at all, but they resemble the color after the dry season, when the grass turns from green to brown. In the northeastern part of Thailand, 466 miles away from Bangkok, is a 75-million-year-old rock formation sticking right out of the mountains. Their shapes look just like a pod of whales swimming together. No wonder this place is called Three Whale Rocks. Millions of years ago, this area was just a desert, but this land has changed quite dramatically during this time. These sandstone mountains were lifted up by plate tectonics, that's the shifting of the crust layers, called lithosphere, and erosion by the Mekong River, resulting in the strangely shaped rock formations we see today. Salar de Uyuni in Bolivia is the world's largest salt flat. At 4,050 square miles in size, it's twice as large as Grand Canyon National Park. After winter has passed, the salt lake is transformed into a beautiful giant sky-reflecting mirror between September and May. With salt all the way to the horizon, it creates an illusion of endlessness. The thin layer of water left over from ice melting creates a shimmering effect of the sky, making it one of the best places to visit in the world. The Catambo River in Venezuela might be the stormiest place in the world, with nearly 300 storm days a year. The lightning storms are so consistent, and they're predicted 3 months in advance. During the wet season in October, you might see 30 lightning flashes in a single minute. At sunset, strong winds flow around the 3 surrounding mountains, forming storm clouds over the water. When the water droplets of humid air collide with ice crystals from the cold air, the static charges cause a lightning storm that happens nearly every night. Off the southern tip of Japan lies the Yonaguni Formation. Archaeologists believe that the monument belongs to a fabled Pacific civilization, like Atlantis, that vanished beneath the waves thousands of years ago. If it's truly a lost civilization, or just nature having a little fun, this is the site to dive into. Features inside the structure resemble stonework like castles, temples, and a stadium, connected by roads and what seems to be large walls all the way around. There are even marks in the stone that appear to show quarry work, faded faces, and rocks sculpted into animal shapes. Some scientists believe that the symmetry of the stones is not as straight as reported. It appears solid rock rather than carved blocks, weathered down by all the water over many years. Plitvice Lakes National Park in Croatia is an interconnected chain of waterfalls, the tallest being 230 feet, and underground water channels, creating natural dams and lakes in such a picturesque environment. Found in the deep woodlands surrounded by meadows brimming with wildflowers, brown bears, gray wolves, lynx, deer, and plenty of rare bird species for birdwatchers call these 115 square miles of the national park home.
You're strapped in a boat cruising down the Amazon River with the sun scorching hot. As you check out your map, your boat starts rocking back and forth. The water is starting to get more intense, so you hang on for dear life. You tuck your map in your pocket and try to take control of your boat. You strike some jagged rocks and duck low to avoid tree branches. Your boat strikes a large rock out of nowhere and capsizes. You're swimming in the murky green water. While you're trying your best to get ashore, your boat gets washed away. Underneath the water lies a whole new world of bizarre and dangerous animals. Candiru fish are snake-like creatures that can grow up to 16 inches long. Arapimus can weigh more than an adult male and are taller than most basketball players. They're the biggest freshwater fish in South America. They have a hybrid gill system that forces them to pop up to the surface every 5 to 15 minutes to breathe in oxygen for their large swim bladder. You swim out of the raging water and dry yourself off. Oh no, your map is completely soaked. There's no way you can get to your destination without it. You venture into the thick rainforest, shoving the branches and leaves away. As you get deeper, you notice something on a tree. It's barely moving, but it's got sharp claws and a raggedy coat. It stretches its arm to another branch and tries to pull itself up, ever so slowly. Sloths sleep more than half their days and only head down from trees once a week. They're so motionless, they sometimes grow algae and moss on their fur. The rainforest gets denser with each step until there's barely any sunlight illuminating the path in front of you. You notice a figure following you. With every branch you step on, you can hear a faint sound right next to you creeping around. You start walking a bit faster, and the sound catches up with you. You make it out of the dense part and tread along a narrow path until you reach a cliff. You can't walk normally here, so you pin against the wall and walk sideways to cross the hills. You slowly move across with the river 30 feet below you. You move your right foot, and some rocks fall into the river. You keep going and misstep. You're about to fall, but you hold on to a large tree branch and pull yourself up. You notice a couple of colorful poison frogs inches away from your fingers. Touching any of these frogs can be extremely dangerous and harmful, despite their amazing color patterns. The golden poison frog is one of the most poisonous animals in the world. One of them hops right next to you, so you let go of the branch and fall back in the river. The river is washing you down until you reach a calm current. Underneath you is a swarm of piranhas swimming with their sharp teeth. The red color on their skin is unmistakable, so you swim off like an Olympic athlete. Piranhas will eat anything that gets in their way, no matter the size. You grip onto a log and climb up a small rock to catch your breath. There's a huge electric eel underneath the rock. Despite their name, they're more related to catfish than eels. They use their powerful 600 volts of electricity to defend themselves and catch food. You're stuck, unless you're like the common basilisk that can run on the water like a jet ski. These incredible lizards have special webbing on their toes and can run the distance of a basketball court. You hop on a bunch of rocks until you reach the land. You continue walking along the riverbank until you come across a moving rock. You rub your eyes and see it moving again. It's a dinosaur-looking turtle that resembles a crocodile with armor. The mata mata is a freshwater turtle that disguises itself with its surroundings to catch prey. Their heads stretch longer than their bodies. You shimmy your way past it and continue. You head back into the rainforest and find a spot to rest. Wait, there are giant ants everywhere. They're the biggest ants in the world and can produce one of the most painful stings out there, even comparable to a wasp's sting. You immediately get up and find another place to rest. As you continue walking along, you notice the same feeling of something following you. You can hear some leaves rustling, but it's getting dark and there's no way of telling. You find a nice little spot to build a campfire and catch some Z's, but in the Amazon, everything is a threat. Except for those cute capybaras wandering around. They live in groups next to water sources. They're also the biggest rodents in the world. You don't need to worry about them if you're stuck in the middle of the Amazon rainforest. Suddenly, you feel something slithering up next to you. You look down and see a massive green anaconda just about to constrict you. They are the heaviest snakes in the world and can grow up to 20 feet long and have a huge appetite. You get up and sprint your way out of there. All right, you found a decent cave to crash in. It's daytime again, and you're still alive. You continue walking along the rainforest. You were able to find some breakfast to boost your energy for the rest of the day. You spot something on a tree that looks like a branch, but it's actually a potu, a master of disguise that can spend days motionless on broken tree branches. These bizarre birds use those branches as their permanent home, where they lay their eggs and chill all day. You continue your way through the rainforest and see a Brazilian wandering spider crawling on a tree branch right in front of you. 8 of these species can be found in the Amazon area. They are some of the most aggressive and venomous spiders out there. So, you make a big detour and walk away from it. You feel someone walking next to you again, but you still can't figure out what it is. You see a steep cliff with a waterfall hitting a large lake ahead of you. Looks peaceful, until you see a team of black caimans gathering around the shore. They're the biggest predators in the whole Amazon ecosystem and feed on anything that moves. It's a good thing you're on high ground, otherwise, whoa! You slip and fall down the river, right on the deep end. So far, no caimans spotted you. You swim underwater and try to get to the opposite end of where the reptiles are. As you climb out and dry yourself off, you notice some large black spots on you. You try pulling them off, but they've latched on pretty hard. The Amazon giant leech finds its target by tracking movement and shadow. Once they attach themselves to the skin, it's extremely difficult to extract them. The best way to do so is to slide your finger next to its mouth and pull it off slowly. Ugh. You manage to get them off your body and see that the caimans are swimming towards you. You're pinned to the wall with the lake of hungry reptiles approaching. Suddenly, a pink dolphin jumps out of the water and splashes all over them. They can grow larger than humans and are the celebrities of the Amazon. Scientists think they get their color from the blood capillaries on their skin. The Amazon even has bull sharks swimming around. These carnivorous giant fish are threatening to humans and can swim in both saltwater and freshwater. These sharks prey on anything within their reach, including other sharks. The dolphin distracted the caimans, so you climb up the cliff and try to find the best way to escape. Opened jaws waiting for you to fall into the pit are right below you. You're lucky enough to escape to the top, but as your arms pull you up, the first thing that you see is a jaguar looking straight at you. It's the creature that's been following you this whole time. You get up while it starts circling you, timing its strike. You know that you can't take on a jaguar, nor can you outrun it, so you grab a large tree branch from the ground to defend yourself. It jumps at you, but you duck down in time. The jaguar lands in the water far away from the caiman crocs. It's a good thing these large kitties are excellent swimmers. You pick yourself up and continue. And to your surprise, you find your boat again. You fix it up and sail your way out of the Amazon. Whew!
When you look at the seas and oceans on a map, you might think that they just flow into each other. Like there's really only one big ocean and people just arbitrarily gave different names to its different parts. Well, guess what? You'll be amazed at how much more substantial the borders between them actually are. For example, the border between the Pacific and Atlantic Oceans is like a literal line between two different worlds. It looks like the two oceans meet at an invisible wall, which does not let them flow into each other and mix their waters. Why on earth does that happen? Obviously, there's no actual invisible wall inside, and water is just water. So what could be interfering with its mixing? Well, the thing is that water isn't just water. There can be different kinds. The Atlantic and the Pacific Oceans have different densities and chemical makeups, the level of salinity and other qualities. One can see by their color that they are far from the same. Borders like this, between two bodies of water with different physical and biological characteristics, are known as haloclines. Jacques-Yves Cousteau discovered one of them while he was deep diving in the Strait of Gibraltar. The layers of water with different salinity looked like they were divided with a transparent film, and each layer had its own distinct flora and fauna. Haloclines appear when water in one ocean or sea is at least 5 times saltier than in the other. You can create a halocline at home if you pour some seawater or colored salty water in a glass and then add some fresh water on top of it. The only difference is that your halocline will be horizontal and ocean haloclines are vertical. For those of you who were paying attention in chemistry class, you might remember that if you have two liquids with different densities in one space, the denser liquid should eventually end up below the less dense one. By that logic, the border between the two oceans should look not like a vertical line, but a horizontal one, and the difference between their salinity would become less obvious the closer they got to each other. So, why doesn't it work like that? Firstly, the difference in density of the two oceans is not big enough for one of them to sink down and the other one to rise up, but it is big enough to not let them mix. Another reason is inertia. There's an inertial force known as the Coriolis force, which influences objects when they are moving in a system of axes, which in turn are moving as well. In simpler terms, the Earth is moving, and all the moving objects on it are carried along. acted upon by this Coriolis force, deviating slightly from their natural course. As a result, the objects on the Earth's surface don't move straight on, but deviate in a curve, clockwise in the northern hemisphere and counterclockwise in the southern. But because the Earth is moving slowly, after all, it does take the planet a whole day to make a full circle around its axis, the Coriolis effect isn't easy to observe in the short term. It becomes easier to notice only in long-term intervals, like with cyclones or ocean flows. And this is why the direction of flows in the Atlantic and the Pacific Oceans is different. This difference also doesn't let them mix. Another important difference between these two ocean waters is the strength of molecule connection, or surface tensile strength. Thanks to this strength, molecules of the same kind hold on to each other. The two oceans have totally different surface tensile strengths, which also doesn't let them mix. Maybe if the waters were completely still, they could gradually start mixing over time, but as they flow in opposite directions, they just don't have time to do this. We think that it's just water in both oceans, but its separate molecules meet for just a very short moment and then get carried away with the ocean flow. But if you think that it's only the Atlantic and Pacific Oceans that don't get along with each other, you are sorely mistaken. There's lots of places on the planet where the waters of the two seas or rivers don't mix, and for even more weird reasons. For example, there's a different kind of border called a thermocline. These are borders between waters of different temperatures, like between the warm water of the Gulf Stream and the much colder North Atlantic Ocean. But the most interesting kinds are called chemoclines. These are borders between waters having different microclimate and chemical makeup. The Sargasso Sea is the biggest and most widely known chemocline. It is a sea within the Atlantic Ocean, which has no shores, but is very obviously distinct. You can't not notice it. Let's now take a look at some other spectacular clines we have on planet Earth. And just as a heads up, I might mispronounce some of these names coming up, so please forgive me. First up, we have the North and Baltic Seas. These two seas meet near the Danish city of Skagen. The water in them doesn't mix because of different densities. Sometimes you can see the waves of the two seas clash into each other, making foam. Their waters do mix very, very gradually. That's why the Baltic Sea is slightly saline. If there had been no water coming to it from the North Sea, it would have just been a freshwater lake. Next up, the Mediterranean Sea and the Atlantic Ocean. They meet at the Strait of Gibraltar and have both a different density and salinity. So there's two reasons their waters don't mix. Then we have the Caribbean Sea and Atlantic Ocean. The place where they meet is near the Antilles, and it's very easy to spot. It looks like someone has painted water with two different shades of blue. Another place where these two meet is Eleuthera Island of the Bahamas. The Caribbean Sea water is turquoise, and the Atlantic Ocean water is dark blue. There is also the Suriname River and the Atlantic Ocean, which meet near Paramaribo in South America. How about the Uruguay River and its afflux? These two meet in Misiones province in Argentina. One of them is claimed to be used in agriculture, and the other has an almost red tint to it because of loam during rainy seasons. Here's an interesting one. The Rio Negro and the Solimões rivers, part of the Amazon River. 6 miles from Manaus in Brazil, the Rio Negro and Solimões rivers flow into each other, but don't mix for about 2.5 miles. The Rio Negro is dark and the Solimões is light. They have different temperatures and speeds of flow. Then there's the Moselle and Rhine rivers, which meet in Koblenz, Germany. The water in the Rhine is lighter than that of the Moselle. Okay, how about 3 different bodies, like the Ilz, Danube, and Inn rivers? The junction of these 3 rivers is in Passau, Germany. The Ilz is a small mountain river to the left, the Danube is in the middle, and the Inn is a light river to the right. The Inn is wider than the Danube here, but is still its afflux. Take a look at the Alaknanda and Bhagirathi rivers, which meet in India. Alaknanda is dark and Bhagirathi is light. I really hope I got those right. The Irtysh and Ulba rivers flow into each other in Kazakhstan, near the city whose name is Ust-Kamenogorsk. The Irtysh has clean water, and the Ulba's water is cloudy. Moving further east, the Jianling and Yangtze rivers meet in Chongqing, China. I really hope that's close at least. The Jialing is clean and the Yangtze is brown. The Irtysh River actually has another intersection with the Om River. These two rivers flow into each other in Omsk, Russia. Here, the Irtysh is cloudy and the Om is pure and transparent. Speaking of Russia, the Chuya and Katun rivers meet in the Altai Republic. The water of the Chuya has an unusual cloudy white color here and looks dense and thick. The Katun, by contrast, is clean and turquoise. Flowing into each other, they form a single two-colored stream that does not mix for some time. On the other side of the globe, we have the Green and Colorado rivers. The place of their junction is National Park Canyonlands in Utah, USA. The Colorado River is brown and the Green is, well, green. The corridors of these rivers go through rocks with different chemical makeup. That's why they have such a big contrast of colors. Last but not least, we have the Rhone and Arve rivers. They flow into each other in Geneva, Switzerland. The Rhone is a pure river that flows out from the lakes of Geneva, while the Arve is cloudy and gets its water from the glaciers of the Chamonix Valley. This is by no means an exhaustive list of all the strange climes on our beautiful planet, but as you can see, it happens a lot more often than you think. These are the kinds of environmental oddities that can really teach you about the way the natural world works. If you're curious enough, of course. Thanks for watching. Oh, and let me know how well I did with the pronunciations. Constructive feedback is always helpful.
These people can spend more than 5 hours a day underwater. And this must be the closest thing we have to actual mermaids. Meet the Bajau tribe from Indonesia, Malaysia, and the Philippines. This tribe developed an extraordinary mutation, which helps them to almost live in the sea. Known as the nomads of the sea, they've been living near the waters of the Sulu Sea by the Philippines for nearly 1,000 years. Looks like Moana's got competition. Look at their houses. They're built on stilts, and there's a reason for it. These are the traditional lancha houseboats, which are great for getting to the water as often as possible. These little huts can fit a family of 5 and sometimes a community with up to 30 roommates. They're super easy to build. One hut can be completed in only 3 weeks. This also allows the Bajau to move freely across the seas. Since they lived in such a watery climate for generations, thriving on spearfishing and collecting shellfish, they started getting unusual mutations. You're probably thinking about superpowered lungs, but no. They actually developed bigger spleens than the rest of the world. It's 1.5 the size of a normal human. Why is it important? Because the spleen helps store oxygenated red blood cells, so having a bigger one is like having a natural scuba tank. This adaptation is similar to what happens in deep diving seals, which also have large spleens. Scientists found that they have a special gene called PDE10A that's responsible for this. Bajau can hold their breath for about 10 minutes. For comparison, a regular human can do that for about 30 to 90 seconds. And the world record is 24 minutes and 37 seconds. They also spend up to 60% of their day underwater. And you'll never guess what diets they have. Of course, they eat a variety of sea creatures, especially lobsters, snails, and sea cucumbers, which are known for being very nutritional and even medicinal. They build their boats themselves, fish using traditional methods, and trade their surplus catch with the mainlanders for essential supplies. They also use this money to buy cassava and prepare their cultural dish called cassava pangikai. Since they don't have fridges, they line up tons of caught fish and sun-dry it. Thanks to this technique, the fish can last for weeks. People from this tribe are yet to develop gills and scales, but they have their underwater quirks. When they hold their breath and dive, their bodies go into a special mode where their heart rate slows down and their spleen squeezes out extra oxygen into their bloodstream. Usually, Bajau uses traditional wooden goggles and weighted belts. They also have incredible freediving skills. They've conquered depths of over 230 feet. They start learning how to swim at about 8 years of age, or even younger. At the same time, they learn to hunt and survive in general. The Bajau people also make their own sunscreen. It's an everyday sunscreen called Borak Buas. It's mostly based on turmeric and rice powder, and women use it to protect their skin from the strong sun rays. It's a simple and cheap way to protect beauty, so it's especially popular among unmarried Bajau women who want to attract a potential spouse. But it's not all smooth sailing. In the 1950s, the Malaysian government put the Bajau in a pretty difficult legal position. After living for centuries as unrestricted nomads, now they have to carefully navigate its journeys across national borders and bureaucratic hurdles. This means that they're not fully stateless, but they're not officially recognized citizens of any country. Today, only a few hundred Bajau families live near Semporna, Malaysia, but it's getting harder to live such a life. The resources are scarce, and recently, some new restrictions appeared on cutting trees for boat repairs. All these things are slowly pushing them towards a more settled yet uncertain life on land. They're forced to resettle in places like the Bangau settlement, but without citizenship, they essentially have no formal rights for things like getting jobs or education. Modern life poses tons of challenges for them. Imagine seeing millions more colors than everyone else. That's what tetrachromats can do. Tetrachromacy is a condition where someone has an extra type of cell in the back of their eye. This allows them to see a broader range of colors. If an average healthy person sees about 10 million, then tetrachromats might see 100 million. The extra cone enhances their ability to differentiate between subtle shades that others might not notice. This mutation requires 2 X chromosomes, so it actually happens to women. And it's not like this is a super rare thing either. The study says that about 12% of women possess this unique condition, and that's a huge number. Most tetrachromats don't even know they have this super vision. They might not realize they're seeing more colors than an average person. This makes spotting tetrachromats and studying them kinda tricky. And since scientists themselves usually can't see more than about 10 million colors, it's also pretty hard to test people for this condition. But they think that, like with X-Men, after some special training, tetrachromats might unlock the full potential of their ultra abilities. Marfan syndrome is a genetic condition that affects the body's connective tissues, making them more elastic. This can make you unusually tall, have elongated limbs, and often be extremely flexible. And some people use this as an advantage in their careers. Javier Botet was diagnosed with Marfan syndrome at a young age, but he made a name for himself in the horror film industry. He can contort his body in such an eerie and unsettling way that this has landed him roles in numerous films, such as Mama, The Conjuring 2, It, and Slender Man. But Marfan syndrome is a spectrum disorder. While some people with the condition can live relatively normal lives, others may face serious health issues. Do you sometimes wish that there was less sleep so you'd have more time? Well, some of us got that blessing. While most adults need 7 to 9 hours of sleep each night, some people can function well on only 4 or 6 hours. This genetic mutation, found in a gene called DEC2, actually influences many different species, not only humans. For example, it also works on mice and fruit flies. DEC2 helps regulate circadian rhythms, the natural biological clock. This mutation affects the production of orexin, which is a hormone involved in wakefulness and maintaining the sleep-wake cycle. Basically, it helps release morning hormones earlier than usual and fades away before dawn. They discovered this gene in a family of natural short sleepers. It was a bunch of people who go to bed at a normal time, 11 p.m. to midnight, but wake up at 5 in the morning without any issue. It's a super rare mutation. It might sound like something out of a comic book, but humans can actually have super strength. Turns out, some accidental mutations can unleash titanic strength without any crazy workout routines. There are 2 proteins in our body, myostatin and activin A, that usually are secreted by muscle cells to suppress excessive growth. In other words, these 2 help regulate the size and number of your muscle cells, so you don't end up accidentally looking like Schwarzenegger. But as you can guess, some do end up like that. People with this genetic condition don't produce these proteins. Without hitting the gym, they can naturally grow their muscles extraordinarily large, resulting in super strength. It's called myostatin-related muscle hypertrophy. Sounds kinda dangerous, right? And it is. When you become a Superman, there's also the risk of muscle imbalance, heart and joint issues, and other problems.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions. When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animals' response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, it's being monitored closely for any concerning activity. Apart from these 2 being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
The concept of oil on troubled waters may seem like a strange expression, but its meaning of calming a tense situation is well understood. The origins of this phrase, though, have a much more literal explanation. It's true that even the roughest waves can be subdued by simple oil. Just like you dress your salad with oil to make it nicer, you can dress the sea to make it calmer. At the end of the 19th century, captains from various ships shared their experiences of using oil to calm rough waves in letters to the New York Times. One of those captains, Olsen of the Norwegian bark Wilhelmine, detailed what he did to save his crew and ship during violent storms. Despite the challenges they faced, the oil trick proved to be a game changer, drying up the weather side of the deck and helping them navigate through heavy gales. His words hinted at a secret power hidden within these simple bags made of sailcloth filled with irregular animal oil. He used it several times, and each time, the technique worked like a charm. One time, his crew encountered heavy gales on their voyage to Belfast. They were causing quite a stir, but they managed to stay ahead of the game by deploying these bags made of sailcloth filled with animal oil. As soon as they released the bag from the cathead, the weather side of the deck dried up in no time, even as the seas continued to wash over it. It was pretty neat to see it working its magic without even needing to check if the bag was empty, as it was a real lifesaver. Their vessel was still a little shaky and taking on water on the lee side, but this little trick really helped them out. Captain Jenkins from the British steamer Francisco used a similar method to calm the seas during their voyage from Hull, England to Boston. They ran into some strong westerly gales, causing really big waves. They didn't want to head any further north, so they decided to stop the engines and chill for a bit. They stuffed some oakum into the pipes of the closets and filled them with oil, and it worked like magic. The sea calmed down along the side of the ship. The big waves disappeared, and they stayed nice and dry. In total, 12 masters shared their success stories of using oil against rough waves, with only one reporting that it didn't work as expected. The use of storm oil, as sailors called it, was a tried and true method of preserving crew, cargo, and livestock from the harsh sea conditions. The toughest thing some of them experienced was just a little spray. Their methods were a tad different, but all of them used oil. But what made this storm oil so effective? First off, let's clarify something. Storm oil is not your average supermarket olive oil. To be truly effective, storm oil must be made of that thick, next to water insoluble consistency. Technically, it acts like a surfactant. This practice is very old and has been used for many centuries. Since ancient times, people have poured oil to calm ocean waves. It was poured onto the ocean surface to reduce wave intensity, making it easier for sea rescuers and navigation. This spilled oil accumulates on the surface and creates a concentration gradient that leads to extra dissipation and damping as waves move. In the past, steamships and lifeboats from various countries were required to carry storm oil as this practice continued until the late 20th century. It was included in the United States Maritime Service Training Manual as essential equipment for lifeboats, and British vessels were mandated to have it until 1998. Often, vegetable oil or fish oil was used as a cost-effective option. While those options were commonly used as storm oil substitutes, the thick consistency was the key to the oil's effectiveness. Storm oil has a dampening effect on water, absorbing some energy from the waves. It quickly forms a thin layer over a large area of the water surface, preventing wind from creating waves easily. The use of oil to calm ocean waves dates back to ancient times, with Aristotle and Pliny the Elder discussing its effects. Benjamin Franklin famously studied the calming properties of oil on waves during his trips to England in the 18th century. Communication between Franklin, William Brownrigg, and Sir John Pringle led to further exploration of this phenomenon. Agnes Pockels also made significant contributions to the study of storm oils through her experiments in Germany. She suggested that the calming effect of oil on water involved more than just reducing surface tension. Oil is definitely a game changer when it comes to calming rough seas. But it's not just any oil that does the trick. You gotta use the right kind of oil and apply it the right way. Forget engine oil and other petroleum products, they won't do much. Fish oils are where it's at, especially the thick ones. The problem is, modern ships and boats don't really carry fish oils, so folks end up using engine oils and bunker oils instead. Not surprising that they don't see the calming effects they were hoping for. Back in the day, the Coast Guard used to carry a little tank of oil for rescue missions in choppy waters, but they stopped that practice ages ago. You can't just pour the oil on the water. You gotta let it leak out gradually, drop by drop. The best way is to hang a bag of cod liver oil or something like that over the side of the boat. The oil seeps out through the bag onto the water surface and smooths out the waves. Not only does the oil calm things down, but it also stops the wind from messing with the surface. Just a bit of the right oil, like a gallon or so, can flatten out a huge area around the boat. Believe it or not, tossing oil into the sea used to be allowed. Steamships and lifeboats were actually required to have equipment to slowly release oil during storms. The lifeboats on the Titanic fell under British law from 1894, which said they had to carry oil for bad weather. Now for the science part, as oil decreases water's surface tension, preventing those pesky waves from breaking. It's like adding an invisible layer over the water that makes it super smooth. So, when you pour some oil into water, the molecules don't clump up as they spread out to form a super thin layer. These oil molecules kind of do a somersault, standing on their heads and aligning with the water molecules like magnets. This creates a film on the water surface that is just one molecule thick. You can actually figure out the size of a single oil molecule by trying this out. For instance, one tester used a spoon that was under half an inch high, and the oil spot it spread out on the water was massive. If you do the math, you'll see that one molecule is incredibly tiny. Usually, wind creates waves by moving the surface of the water, but a layer of oil molecules acts as a barrier, stopping the wind from making waves and just pushing the oil around instead. This pretty cool trick has been used by all sorts of people throughout history for different reasons. I've already mentioned that Benjamin Franklin studied this phenomenon a lot, but he also liked to prank people by using this science. He would claim he could calm a choppy lake with just the touch of his cane. Turns out, he had a little vial of oil in the bottom of his cane that he could tap out onto the water surface. It made him look like some sort of magician or water-bending master. By the way, the science behind this trick is still used today. By putting a thin film of oil or smaller molecules like magnesium fluoride on glass, you can create invisible glass that reduces glare and reflection. This type of glass is used in smartphones, tablets, laptops, and glasses. Meet Hula Male, also known as the City of Hope. This nickname makes total sense since this artificial island is part of the Maldives' big plan to avoid being completely submerged in the near future. Hula Male was created by placing sand from the seafloor onto a submerged coral platform, and it worked. This city sits about 6 feet above sea level, which means it's twice as high as the Maldives' capital, Male. While more and more people are moving there to live, the island was also designed to serve as a temporary evacuation site during dangerous storms and typhoons. Seychelles is another gem in the Indian Ocean that's at risk of disappearing. Unfortunately, coastal flooding is becoming a common issue there, especially during spring tides and heavy rainfall. The problem is that their main island, Mahé, hosts about 90% of the country's population. Along the coast, it's only about 6 feet above sea level. Fiji is the third tropical paradise on our list, and it's also a top pick for travelers. But this nation is in a tough spot, since it's located right in the middle of the Pacific Ocean, where huge storms can really turn things into chaos. Take Cyclone Winston. It hit Fiji back in 2016 and ended up costing them over $1 billion in damage. So one thing they're doing to protect themselves is planting mangroves along the coast and preserving the ones that already exist. These trees are awesome since they help reduce wind speed during cyclone emergencies and also combat erosion by trapping sediments. Egypt might be in trouble too. I mean, it's not like the whole country is going to be underwater and we'll only see the tips of the pyramids in a few years. But things could really change for them as coastal cities are facing a serious risk. Take Alexandria, for instance. 45% of its population already lives below sea level. If the city is flooded, not only will everyone have to move, but Egypt in general will suffer a major impact on its fish production. In Europe, one of the most at-risk populations is in the Netherlands, where about half the people live in areas below sea level. In the future, planning a romantic gesture with tulips for your girlfriend could become an impossible mission. The Netherlands is responsible for 2/3 of the world's tulip production. So if fields are taken over by saltwater, it's game over for the blooms. But the good news is that the Dutch have centuries of experience dealing with water, so knowing how to work with storm barriers and seawalls can prevent them from a doomsday scenario. The risks of rising sea levels probably aren't higher anywhere else than here in Tuvalu. This island chain, located halfway between Australia and Hawaii, could be the first state to become uninhabitable. Its stunning land is only about 9 feet above sea level. And just by looking at it on the map, you can see how narrow it is. In fact, the narrowest part in Fongafale is only about 65 feet wide. So even before higher tides become a real problem, the country's limited farmland could be flooded with saltwater. The next country on our list is the Philippines. This archipelago in Southeast Asia boasts some of the most stunning scenery, but it faces the risk of flooding for 2 reasons. First, due to rising sea levels, and second, because of crazy, unpredictable weather. Since 1990, events like cyclones, earthquakes, and tsunamis have cost the country over $20 billion. Have you ever heard of Vanuatu? This chain of islands, spread out between Australia and Fiji, could be flooded soon. Vanuatu was one of the first Pacific nations to relocate an entire community to a safer spot. Back in 2005, residents living in risky coastal areas of the northern island of Tegua moved to higher ground. Next up, the Marshall Islands, a country located in the Central Pacific. Studies show that 40% of the buildings in the capital city, Majuro, could end up underwater in the future. But this country isn't throwing in the towel just yet. They've got a game plan. They are fortifying the infrastructures of their low-lying airport, relocating key buildings to higher ground, and putting up seawalls on rural islands. Heading south, we've got Nauru. This is actually one of the smallest countries in the world, covering just 8.1 square miles. Today, it's home to 10,000 people, but it's on the brink of becoming uninhabitable. Water levels are rising about 3 times faster there than the global average. The Buada Lagoon sparks special concern since it's the only surface freshwater resource, and it's located only 16 feet above sea level. Our next stop in the Pacific Ocean is the Republic of Palau. Rising sea levels are no joke for them either, but protecting their crops, especially taro, is a priority at this moment. About halfway between Hawaii and New Zealand lies Samoa, and this country is dealing with a unique situation. Not only is the volume of water increasing there, but their land is also sinking. You see, a couple of strong earthquakes and tsunamis hit Samoa back in 2009. So as the crust bounces back to its original position, the overall land surface is actually going down. Because of this, their housing and main infrastructure could take a serious hit, especially since all their airports are along the coast. Let's head to Kiribati. This Pacific nation has a big problem with frequent flooding because most of its people and infrastructure are near the coast. Apart from the volcanic island of Banaba, none of Kiribati's land is more than 6.5 feet above the ocean. To tackle this situation and keep their population safe, they had this big idea of making a massive floating platform, kind of like the ones oil companies have. But the problem is that it would cost them a fortune, as the project is estimated to be around $2 billion. If visiting Vietnam is on your bucket list, you better hurry up. The top 10 things to do there mostly involve cruising to jaw-dropping spots like down to Ha Long Bay, also known as the Descending Dragons Bay. But by 2050, the surrounding land over there might be underwater. Another huge problem Vietnam is facing is that the main rice fields are getting salty. And if you're into Vietnamese food, you know how important rice is for them. Right now, they're especially concerned about the Mekong Delta region being vulnerable. After all, this is a highly fertile area responsible for most of Vietnam's agricultural output, with over 50% of it being, rice. This nation is really putting in the effort to adjust to this new reality. They're flushing the rice fields in the Mekong Delta with fresh water to get rid of the saltiness. Our next stop is in the Caribbean Sea. Grenada is an island country, but you may know it as the Island of Spice, since its tropical climate is just perfect for cultivating things like nutmeg, cinnamon, cloves, and ginger. Unfortunately, Grenada and its incredible fertile soil also face an uncertain future of being submerged. Let's talk about the last country on our list, the Solomon Islands. 5 islands in this archipelago have already vanished beneath the waves, and 6 others are submerged by 20%. They include the Nusa Evili Island, which was once a hotspot to go to for a picnic in the early 2000s. Even though the situation is complicated, it's important to note that more than 300 of the islands there are inhabited. One thing about the Solomon Islands is that it seems like they're always in some kind of recovery mode, since the country often gets hit by tropical cyclones and flash floods. Their population is already working hard to save their homes from the rising seas by building stone walls along the coast, planting mangroves, and constructing houses in higher areas.
The protective shield of our planet decays and eventually fails. So do our satellites. First, communication satellites in the highest orbits go down. Next, astronauts in low Earth orbit can no longer contact their mission control center. And finally, hazardous, relentless cosmic rays start bombarding everything on Earth, causing havoc and devastation. Are these the terrifying consequences of the planet's magnetic field reversal we're going to face? Right now, as you're watching this video, Earth's north magnetic pole is extremely out of whack. It's so serious that scientists will have to update the global magnetic field model released a mere 4 years ago. Does it all mean that the magnetic pole of our planet will flip soon? Well, be patient, we'll figure it out a bit later. You see, the magnetic pole is moving quite erratically from the Canadian Arctic towards Siberia, and these movements are very unpredictable. But it's normal for the pole to be moving. There are long-term records from London and Paris that prove that the North Magnetic Pole moves randomly around the rotational North Pole over periods of several hundred years. But the most astonishing thing about its movement is that it's speeding up. Around the mid-1990s, the magnetic pole unexpectedly accelerated from a bit over 9 miles to 34 miles a year. And recently, the pole crossed the international date line, moving toward the eastern hemisphere. The European Space Agency launched extremely accurate magnetic field satellites in 2013. Thanks to them, researchers have superb data they can use not only to make magnetic field maps, but also to update them every 6 to 12 months. That's how they were able to notice that the core field was weakening too. It might be a sign that the planet's magnetic field is about to flip. To understand this process better, we need to figure out how the core field works. Let's say we've got a bar magnet that runs through the center of our planet and has a north and a south pole. This magnet is incredibly strong, representing about 75% of the intensity of our planet's magnetic field at the surface. Our bar magnet is not only moving, but is also getting weaker, by about 7% every century. Admittedly, this bar isn't the perfect representation of the core field. It's more like electric currents generating Earth's magnetic field. Still, this model makes it easier to see what's happening to our planet now. The magnetic field of our planet plays an important role in protecting us from dangerous radiation and geomagnetic activity, which is the product of the interaction between the solar wind and Earth's magnetosphere. Earth's magnetic field also moves. Scientists have been studying and tracking the movement of the magnetic poles for hundreds of years. The historical motions of these poles indicates changes in the global geometry of the magnetic field of our planet, and they may point to the beginning of the field reversal too. That's what the flip between the north and south magnetic poles is sometimes called. You see, if the north magnetic pole moves a bit, it isn't a big deal. But a complete reversal might have a serious impact on the climate of our planet, as well as modern technology. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. So those scary events from the beginning of the video aren't likely to happen to us. The magnetosphere will continue protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current is negative charges called electrons moving through the metal. The current is what generates a magnetic field. Earth has a liquid iron core. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving through the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic radiation, which otherwise would be extremely dangerous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and the magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever. But sometimes, the sun starts shedding gargantuan magnetized clouds of gas that can accelerate to incredible speeds. They're called coronal mass ejections, or CMEs. They're ejected from the sun over the course of several hours. CMEs usually look like giant twisted ropes and can occur spontaneously. Their frequency varies according to the 11-year-long solar cycle. For example, at a solar minimum, you can observe one ejection per day, and when the sun is in its most active phase, there might be 3 CMAs per day. Coronal mass ejections disrupt the calm flow of the solar wind and cause serious disturbances that can damage stuff both in space near Earth, like satellites, and on the planet's surface. If coronal mass ejections make it to Earth, their interaction with the magnetosphere generates geomagnetic storms. Those can trigger auroras, happening when a stream of energized particles hits the atmosphere and lights up. And then there are also solar flares. They develop more rapidly and with much more energy than coronal mass ejections. Solar flares often occur soon after coronal mass ejections. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. A powerful solar storm can potentially cause a devastating global blackout on Earth. If not for the Earth's magnetosphere, the effects of the sun's activity would be much more devastating. Luckily, the magnetosphere deflects most of the solar material hurtling towards our planet from our star at a speed of over 1 million miles per hour. But even so, during space weather events, there's a lot of hazardous radiation near Earth. It can potentially harm astronauts and spacecraft. Plus, space weather can damage large conducting systems, for example, pipelines and power grids, by overloading currents running inside them. Scientists regularly map and track the overall orientation and shape of our planet's magnetic field. To do it, they use local measurements of the field's orientation and magnitude. That's why they've been able to conclude that the location of the North Magnetic Pole has moved by almost 600 miles since the first measurements were taken in 1831. The magnetic field of our planet reverses on a timescale varying between 100,000 to 1 million years. One can tell how often it happens by looking at volcanic rocks at the bottom of the ocean. They capture the orientation and strength of Earth's magnetic field at the time of their creation. So, dating those rocks gives us a good picture of how our planet's magnetic field has evolved over time. From a geological point of view, field reversals happen quite fast, but they are extremely slow from a human perspective. A complete reversal normally takes a couple of thousand years, but during this time, the orientation of the magnetosphere may shift, exposing more of Earth to cosmic radiation. Such events tend to change the concentration of ozone in the atmosphere. In any case, scientists can't say for sure when the next field reversal will happen, but they keep mapping and tracking the movement of our planet's magnetic north. By the way, the Earth isn't the only planet with a magnetic field. Gas giants, like Jupiter, also have a conducting metallic hydrogen layer that generates their magnetic fields. Jupiter's internal magnetic field prevents the solar wind from interacting directly with the planet's atmosphere.
How would you describe the shape of the planet we live on? It's definitely round, but it's not a perfect sphere. Because of the force of Earth's rotation, it's slightly flat on the north and south pole. But there's more to it. The planet's rotation causes its sides to bulge outwards. The best term to describe our home planet is ellipsoid. Earth is nothing more than an oversized lumpy potato. These are the words of Atraji Ghosh, a solid Earth geophysicist from Bangalore. She and her team have been studying something called the Indian Ocean Gravity Hole. Sounds like the scenario for a science fiction movie, but it's very much real. We think of gravity as something consistent. If you drop a pen from your hand in Los Angeles and in Perth, they're going to fall to the floor at the same time. Well, this is not completely true. Gravity is connected with the mass of a celestial body. Astronauts on the surface of our moon don't walk, but move in hops. That's because Earth weighs 81 times more than the moon. Less mass means less gravity. Earth is more massive, so it has a stronger gravitational pull. But there's a catch. All this mass isn't distributed evenly across the planet. As a result, gravity varies as well. NASA has been mapping Earth's gravity field since 2002 using twin GRACE satellites. The maps they produced show where gravity is stronger and where it's weaker. Mountain ranges such as the Himalayas contain a lot of mass. This means they generate a stronger gravity field. The opposite happens in ocean trenches. The deepest of them is the Mariana Trench in the Pacific Ocean. You could almost stack 2 Mount Kilimanjaros inside it. The low concentration of Earth's mass below it means that the gravity field here is weaker. Places on the globe where huge chunks of mass are missing are called geoid lows. A geoid is an imaginary surface that follows the outline of sea levels around our planet. Imagine the Earth without any land. That shouldn't be too hard since the nickname of our home is Blue Planet. Now draw a curvy line along the surface of the oceans, and you get a geoid. In reality, the line stretches across oceans, as well as land masses. Scientists use this imaginary line to calculate the depth of tremors or objects that occur underground. When the wavy line goes down, that's a geoid low. The biggest of them sits at the bottom of the Indian Ocean. The first to discover it was a Dutch geophysicist in 1948. He was performing a gravity survey from a ship. The man noticed that sea levels dipped over 320 feet below the global average. The gravity hole got the official name Indian Ocean Geoid Low. It spans well over 1 million square miles off the southern coast of India. If you went out at sea in the middle of the gravity hole, you wouldn't notice much, just an endless ocean as far as the eye could see. The only way to measure the dip in gravity is through extensive geophysical measurements and calculations. The concept of a gravitational hole existed for nearly 2 centuries in the scientific community, but researchers could study it in high detail only after satellite measurements became possible in the late 20th century. A team of Indian scientists was determined to explain the anomaly that had been puzzling geologists for decades. They used supercomputers to simulate the seismic activity that formed our planet. A total of 19 simulations revealed how tectonic plates moved across the span of over 140 million years. This was during the Cretaceous period, the time when T-Rex roamed the Earth. Nearly a third of the possible scenarios produced a geoid low, similar to the one in the Indian Ocean. The most important factor in these models was the presence of magma plumes. These are places inside the Earth's mantle, where lava flows upwards. The mantle sits between the planet's outer core and the thin crust we walk upon. The magma in the mantle plume is hotter than the surrounding rocks. The heat it generates melts and thins the crust. This creates hotspots that are brimming with volcanic activity. Yellowstone National Park and the Hawaiian Islands sit atop such hotspots. The Indian team of scientists linked the presence of magma plumes to the formation of the geoid low. Their source was an ancient ocean that disappeared tens of millions of years ago. It was located where the Himalayan mountain range sits today. Evidence of this lie in the marine rocks researchers found on the world's tallest mountains. The oceans ceased to exist when India's landmass separated from the supercontinent called Gondwana. It drifted north and merged with the rest of the Asian continent. At the time, the Eurasian supercontinent was called Laurasia. The Indian tectonic plate went down inside the mantle. It ended up under the African continent. This landmass contained a lot of crystallized material which was quite dense. When the sinking plate of the former ocean reached it, plumes of magma spilled out. As a result, low-density materials ended up closer to Earth's surface. Density is used to calculate mass, and if you remember our lesson in physics from the beginning of the video, less mass translates into a weaker gravity field. Scientists believe this is how the geoid low in the Indian Ocean formed some 20 million years ago. At this point in prehistory, the Earth looked a lot like it does today. There were vast grasslands, and whales swam in the seas. Geophysicists who created the computer model cannot tell for sure what will happen in the future. Ghosh thinks it's possible that the gravity hole in the Indian Ocean will remain in place for a long time. But plate movements can also cause the anomaly to fully disappear in the coming eons. Earth's tectonic plates are constantly shifting. They define the shape of our continents and oceans. Experts study plate movements to get a picture of how our world looked millions of years ago. However, telling Earth's geologic future is much more complex. The gravity hole in the Indian Ocean is the biggest, but it's not the only one in the world. Other areas with low gravity include the island of Cuba and the Bahamas. On the opposite side of the spectrum are the Philippines. Here, gravity is stronger than normal, but the poles are the places with the strongest pull to them. They are the closest to the center of the Earth. If you stand directly on the North or the South Pole, you are 3,950 miles from the planet's core. At sea level on the equator, this distance increases by more than 13 miles. Earth's gravitational field also has an effect on your weight. At the equator, you weigh 1% less than you do on the poles. The South Pole is maybe more suitable for this experiment because there is actually ground there. But gravity is the strongest at the North Pole in the middle of the Arctic Ocean. This is where scientists in 2013 recorded the highest gravitational acceleration on the planet. This is the rate a falling object speeds up in free fall. The acceleration depends on the strength of gravity. When a team of researchers from a university in Perth set out to map these gravity changes, they discovered something interesting. Gravitational acceleration was the highest at the surface of the Arctic Ocean. This is something they expect to find, but the location of the lowest acceleration point amazed them. It wasn't on the equator as they assumed. The spot lay more than 600 miles south of it at Mount Huascarán in Peru. Scientists believe that the mountain's height had an effect on the phenomenon. This peak in the Andes is the highest point in the South American country. Hypothetically speaking, if a human falls from a height of 330 feet here, they will reach the ground 16 milliseconds later than if they performed the same stunt in the Arctic. Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank 1 bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for 2 main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least 1 volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones, the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the two regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the high Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, the twilight zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration, as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, the planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 freefall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the Bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produce many unusual sounds and rumbles, but,